Before you do lesson 27, make sure you complete test E in the test masters on circles. Lesson 27 has 3 parts. The first 2 parts are related on multiples and least common multiples, and then we'll talk about some equivalent division problems. Well, first let's just talk about multiples. All those are, like, say you started with 3. 3 times 1 is 3, and some multiples of 3 would be 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, and so on. We'll put those dots there to represent continuing on. Those are multiples of 3. Let's do some multiples of 4 also, just for an example. 4 times 1 is 4, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and so on. Now, just for this particular example, let me add a few more multiples on there because I want to use those to explain the next thing on least common multiples. So we'd have a 21, 24, 27. Just want to add a few on there onto the least common multiples of 4. I could do 4 times 6, 4 times 7, 4 times 8, and that'll be plenty. Okay, now least common multiples, what those are, it's when you're comparing 2 or more numbers and the multiples of those numbers, whatever the 2 numbers they have in common and that are also the lowest. So look at this, 12, both of those have a 12 in common. That's the lowest common multiple between those 2 numbers. Now, they also have 24s in common, right? But those are not the lowest common multiples between the 3 and the 4. So the 12, we call that the LCM for short, least common multiple. Now, right now you're going to learn how to find the lowest common multiple between 2 or more numbers. You'll apply that later when you learn how to subtract and add fractions that have different denominators. In order to do that, you need to find the least common multiple of the denominators. So we've learned about greatest common factors. We use those to reduce fractions to their lowest terms. We also use least common multiples when we work with fractions, but in a different way, which you'll learn about later. Right now, just focus on understanding how to find the least common multiple of 2 or more numbers. So look at these groups of numbers in A and B and find the least common multiple of those numbers. Look at practice problem A, 6 and 10. You can just do that one in your head. You can just think 6 times 5, that'd be 30. 10 times 3, that would be 30. 10 times 2 is 20. 10 times 1 is 10. There's nothing else that would work besides 30. So that would be the lowest common multiple. Now they would both have a 60 in common as well, right? Because you could do 10 times 6 is 60, 6 times 10 is 60, but that's not the lowest or least common multiple. 30 is. Now let's do B, 2, 5, and 10. Now we're working with 3 numbers. It gets a little more complicated, and you could just think of some different numbers there. You might just want to write them out. 2, you'd start 2, 4, 6, 8, 10. 10 would work because you'd have 2, 4, 6, 8. 2 times 5 is 10. And then 5, you'd have 5. 5 times 2 is 10. And then just 10 times 1 is 10. So there it is. The lowest common multiple between those 3 numbers is a 10. Now let's get a little more challenging. How about 30 and 18? There's a little trick that you can do using prime factorization to figure out the lowest common multiple of larger numbers like that. What you do is you find the prime factors for each number first. So 30, that's 6 times 5, or 2 times 3 times 5. 18, that's 9 times 2, or 2 times 3 times 3. Now what you do to figure out the least common multiple is you pick the factors that are used in each number, and we have a 2. Both numbers have a 2, and they have just one 2, so we'll write that 2 down. Both of them have a 3, but the 18 has 2 3s, so we use the factor that's used more, and we write it 3 times 3. And then there's a 5 in there too. That's another factor that those two numbers have, so we need to use that one as well. They don't have to both have those factors to use them in the least common multiple. You use all of the prime factors that you see, and when both of them have the same prime factor and one of them has it more times than the other, you use the one that has it more times. You write it down that many times. And here we have 2 times 3 times 3 times 5, or 6 times 15. That would equal 90. So 90 is the lowest common multiple between those two numbers, and that would have been a little bit more difficult to find. I mean, if you're more comfortable doing it the other way, where you write out all of the multiples and then whichever ones come up first that they both have in common, that's the least common multiple. I mean, you can do it that way if you want to, but this way is just a little bit more of a shortcut and a little bit easier to do sometimes, especially if your least common multiple is really, really big. For example, look at practice problem D. Why don't you try to do that one on your own? Find the lowest common multiple between those two numbers. And so you break both of those into their prime factors. 40 would be 8 times 5, or 2 times 2 times 2 times 5. 75, that's 3 times 25, which would just be 3 times 5 times 5. Now you just pick all of the factors that they both have. And the 40 has 3 2s, so we use all 3 of those 2s. The 75 has a 3 in there. We need to put that in. They both have 5s in them, but the 75 has 2 of them, so we use the one that has more. 5 times 5. So this will be a little bit bigger number here. We'll have 8 times 3 is 24 times 25. That's equal to 600. Now that, if we would have written out all the multiples of 40 and 75, that would have taken us a little bit longer to find the lowest common multiple. Using the prime factorization method, though, it was pretty quick and easy. Now let's change gears a little bit here and go to the last part of this lesson on equivalent division. Division can be kind of complicated sometimes. It's probably the most complicated of the 4 operations, and you want to try to find ways to make it a little bit simpler. For example, if you had 2 divided by a half, what you could do there is if you multiplied both of those values by 2, put a 2 here, and then this, you can just think of that as 2 over 1 to help you do the multiplication. Wouldn't you just have 4 divided by 2 over 2, or 4 divided by 1? That's a whole lot easier to think about. That's 4. But that's an equivalent division problem. Think about it like this. Remember, you can always write a fraction as a division problem, or you can write a division problem as a fraction. So you could say 2 over 1/2. And we multiplied both of those values by 2. That's what we just did. You end up with 4 over 1, or 4. Now, isn't that a whole lot easier to do that than to think about 2 divided by half? It's the same thing, though, because 2 over 2 is equal to 1, right? That is equal to 1. We just basically multiplied by 1. You can create equivalent division problems if you multiply the dividend and the divisor by the same number. And that's helpful because sometimes it lets you see really quickly a whole number problem instead of a problem with fractions, and it's always easier to work with whole numbers than it is with fractions. It's just a little bit easier on your brain, I guess is one way you could think about it. And sometimes you can get to the answer a lot faster doing it that way. So look at practice problem E, for example, 4.5 divided by 1.5. Just do an equivalent division problem by multiplying both of those by 2 first. Well, 4.5 times 2, that'd be 9, right? And 1.5 times 2 would be 3. And you can do 9 divided by 3 in your head. That would just equal 3. So that problem was simplified quite a bit by just doing an equivalent division problem. And what you have to do, you just have to think of what you could multiply both of them by to simplify it, to get rid of your fraction. Now why don't you do F, G, and H, and you just try to figure out a way that you could solve those problems mentally, either by multiplying both numbers by something or dividing both numbers by something to just make an equivalent division problem. Now on F, what I would do on F is just divide both of those mentally by 100, and I'd end up with 260 over 2, which would just equal 130. Now if you did something a little bit different but it was just as quick, then use your method. I mean, there's more than one way to do these. On G, I changed the $4 into cents. 400 over 8, I could half both of those, divide both of those by 2. 200 over 4, divide them again. 100 over 2. 100 over 2 is real easy. That's just 50 cents. So I could say 50 cents, or you could write it in dollar terms like that. And then on H, 120 over 5, well, what I would do there is multiply both of those by 2 and get an equivalent division problem of 240 times, or 240 divided by 10. Dividing by 10 is real easy. You just move the decimal place over. 240 over 10 would just equal 24. Just like 120 divided by 5 equals 24. So on equivalent division problems, to make those, you can multiply above and below by the same value, multiply the dividend and divisor by the same value, or you can divide each one of them by the same value. Think about what you're doing when you divide both of them by the same value. You're reducing a fraction, right? A division problem is the same thing as a fraction. That's what we've been talking about a little bit in this lesson, and we talked about it before too. You just have to think of them that way. Fractions, division problems, those are the same thing. I don't know about you, but taking the longest possible time to do your math homework, that just doesn't sound like a real good idea to me. So doing this equivalent division, multiplying above and below or dividing above and below till you get something you can do in your head, a lot of times that's a really good choice, a really good way to do it, and it'll speed things up for you. Okay, well that's all for lesson 27.